In section 3.5, we talk about equivalent statements and variations of conditional statements. So in this section, we're going to use those truth tables we've learned to make and logic to unravel the verbal morass of conditional statements. So equivalent compound statements are made up of the same simple statements and have the same corresponding truth values for all true-false combinations of these simple statements. If a compound statement is true, then its equivalent statement must also be true. Likewise, if a compound statement is false, then its equivalent statement must also be false. Truth tables are used to show that two statements are equivalent. When translated into English, equivalencies can be used to gain a better understanding of English statements. So we want to show that P or not Q and if not P, then not Q are equivalent. So we need to set up a truth table for both of these statements. So we're going to put two truth tables into one, essentially. So let's just look at the first statement. We still want to set up our P and Q like what we have been. True, 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 false, false, true, and false, false. I'm going to consider not Q so that I can figure out this or statement. And so all we do is we negate that second column. So we've got false, true, and false, true. Now we can find the or statement pretty easy. So this is true as long as one true statement is present. So looking at the the first and the third column, we have true, true, false, true. We're just going to highlight this column for now. Now let's go ahead and look at the other statement. I have most of it already listed on the truth table. The only piece I'm missing is the not P portion. So we want to negate everything that's in the first column. So we have false, false, true, true. And so now looking at if not P, then not Q. Looking at the fifth column and then the third column, we end up getting true, true, false, and true. And so when we're looking at equivalent statements, we want to look at these two columns and see that their truth values are exactly the same. And they are. So that means they are equivalent. So we're going to write a statement that is equivalent to the bill receives majority approval or the bill does not become law. So let's go ahead and write our simple statements for P and Q. So P will be the bill receives majority approval. And Q will be the bill becomes law. So the statement that they're giving us in symbolic form would be P or not Q, which is the first statement we found in the truth table above. Well, we know that's equivalent, and we use 3 horizontal lines to show equivalency. We know it's equivalent to the statement, if not P, then not Q. So using our statements that we just wrote down, if the bill does not receive majority approval, then the bill does not become a law. And so, like I said, the special symbol, it's 3 horizontal lines, is to show that 2 statements are equivalent. And so we can write them in either order, it doesn't matter. So example 2 wants to show that not P is equivalent to P. This would kind of just make sense in general without the truth table. You're doing a double negation, which end up canceling. And so we're just going to set up a very small table. So let's set up our P. And we only have two truth values. It's either true or it's false. And let's just do the regular old negation of P first before doing the double negation. And that just flips the truth values. And then doing the double negation, you're now negating the second column. And so we go back to true and then false. And so we want to see if this third column has the same truth values as the first column. And they do. And so this sentence illustrates the double negation of a statement is equivalent to the original statement. For example 3, we want to select the statement that is not equivalent to Miguel is blushing or sunburned. So let's go ahead and write what P and Q are. So P would be that Miguel is blushing. And Q would be Miguel is sunburned. And so the original statement that's given over here is P or Q. Let's go ahead and write each of these as the symbolic statement so our truth table will be easier to look at. So if Miguel is blushing, then he is not sunburned. So that's a conditional statement. If P, arrow, not Q. Miguel is sunburned or blushing. Well, that's Q or P. If Miguel is not blushing, then he is sunburned. So that's not P, arrow, Q. And the last one is if Miguel is not sunburned, then he is blushing. That's if not Q, then P. So we're going to construct a really big truth table so we can compare and see if we have the same truth values. And so we've got P and Q, so let's go ahead and set up our values. True, 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 false, false, true, and false, false. We need to find the original statement, which was Miguel is blushing or sunburned. So that's P or Q, so that we can compare it with these other 4 statements. And so that is true whenever there's a true value present. So we have true, 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 and then false. And so this is what we'll be comparing these other statements with. So this was the given statement. Now let's look at part A. If P, then not Q. I need to figure out not Q first before I find the whole statement. And so we're just going to negate the second column. So we have false, true, and then we can find the conditional statement, which is part A. So we're looking at the first column and the fourth column. And so this is false, true, true, and true. So this is part A. Does that have the same truth values as this original highlighted table? No, because we have a true and then a false. So this is not an equivalent statement. Part B was Q or P. And so looking at the first two columns, this works the same way as the given statement is. So we have true, 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 and then false. And does that have the same truth values as this third column? And it does. Now let's go on to the third one. If not P, then Q. So I first need to figure out what not P is. And so we're just going to negate the first column. So false, false, true, true. And now I can figure out if not P, then Q. So we're looking at this last column we just did and the second column. And so this would give me a true, 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 and then false. And does that have the same values as the first highlighted column? And it does. So that means that this is an equivalent statement. And we already have the info needed for this last column. If not Q, then P. So we're looking at this fourth column and then the first column. And so we end up getting true, 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 and then false. And does that have the same truth values as the first highlighted column? And it does. And so what that means is that B, C, and D are all equivalent to that original statement. In section 3.4, we learned that if P then Q is equivalent to if not Q then not P. The truth value of a conditional statement does not change if the antecedent and the consequent are reversed and then both of them are negated. The contrapositive of a conditional statement is a statement obtained by reversing and negating the antecedent and the consequent. So that is what we call this statement. It is a contrapositive. If not Q, then not P is the contrapositive of if P, then Q. So you flip the positions and you negate both of them. Now let's look at example number 4. We want to write the contrapositive for each of the following statements. If you live in Los Angeles, then you live in California. So let's write P and Q first. So P would be, you live in LA, and Q would be, you live in California. And so the original statement they're giving us is if P, then Q. And so to find the contrapositive, we flip the letters and we negate both of them. So if not Q, then not P. So in words, that would be if you don't live in Cali, then you don't live in LA. And those are both true statements. Because if you live in Los Angeles, you have to be in California. And if you don't live in California at all, then you can't live in Los Angeles. Let's try the next one. If the patient is not breathing, then the patient is dead. So I'm going to let P be. Patient is breathing. And I'm going to let Q be patient is dead. And so the original statement they gave us is if not P, then Q. And so what we want to do is we flip and negate. So the Q would become first, and we put the squiggle in front of it. But we're going to have a double squiggle on the P, which just gives us the original P. So that is if the patient is not dead or is alive, then the patient is breathing. What about for the third one? If all people obey the law, then the prisons are not needed. So it would be people, or all people obey the law for P. And Q would be prisons are needed. And so our original statement would be if P, then not Q. And so we go ahead and flip and negate. So we'd have a double negative Q, which is just regular old Q, then not P. So if prisons are needed, then, now remember when you negate the all, it becomes some and do not. So then some people do not obey the law. And the last one, we just have letters going on here. And so we want to flip and negate. So that would be a not R. And then we're going to have not the first statement. But those double negatives are going to end up canceling. And you're just left with if not R, then P and Q. The truth value of a conditional statement does not change if the antecedent and the consequent are reversed, and then both of them are negated. But what happens to the conditional truth's value if just one but not both of these changes is made? If the antecedent and the consequent are reversed but not negated, the resulting statement is called the converse. So that's where you flip them, but you don't negate them. By negating both the antecedent and the consequence, but not reversing them, you get the inverse. So you see in the table below, it has variations of the conditional statement. So the conditionals are regular if P, then Q. The converse would be flipping them, if Q, then P. The inverse is just negating both of them, if P, then not Q. If not P, then not Q. And then the contrapositive is where we flip and negate. So if not Q, then not P. If a conditional statement is true, its converse and inverse are not necessarily true. Because the equivalent of a true statement must be true, we see that the conditional statement is not equivalent to its converse or its inverse. So the conditional and the contrapositive have the same truth values, but the conditional and converse do not, and the conditional and the inverse don't. But the converse and the inverse have the exact same truth values. So the conditional and the contrapositive are equivalent, and the converse and the inverse are equivalent. And so the following conditional statement regarding state and national elections in the United States is true. If you are 17, then you are not eligible to vote. Write the statements converse, inverse, and contrapositive. So let's go ahead and write down our statements first. P would be you are 17, and Q would be you are eligible to vote. And so the statement that is in our quotation marks would be if P, arrow, not Q. And this is a true statement because you can't vote until you're 18. Now let's write down the converse. And so the converse is when you just flip the positions. So it'd be if not Q, then P. So if you are not eligible to vote, then you are 17. And that's not necessarily a true statement. There could be other reasons why you can't vote, and so that's false. Let's do the inverse. The inverse is where you just change the negation of both pieces. So that would be not P, then regular old Q. So if you are not 17, then you are eligible to vote. And that's not necessarily true either, because that could be that you're 16, which is not 17, and you still can't vote. So that's a false statement. So we can see the converse and the inverse are both false, which is good. They're supposed to be equivalent to each other. And the last thing is the contrapositive. That's when you flip the two letters and you negate both of them. So that would be if Q, then not P. So if you are eligible to vote, then you are not 17, which is a true statement. If you can vote, then you have to be at least 18, which is not 17, and that's a true statement. So you can see that the original and the contrapositive have the same truth value, and the inverse and the converse have the same truth value.